College-bound days from one of the fastest growing institutions of higher learning in America, the University of Arkansas Community College at Morrilton. We're going to meet one of their esteemed instructors coming up here in just a couple of minutes, but let me introduce Mary Clark, first of all, the Director of Marketing, among many other titles at the university. Great to have you here and great to talk about all the success you guys are having. And I would imagine, Mary, one of the things that is going well for you is you're able to recruit these great faculty members.
That's one of the biggest advantages, I think, of going to the college is you're going to have a lot of unique instructors like Mr. Holtz. He probably sets the bar for uniqueness. But really, one of the biggest advantages of going to UACCM is the close relationships that you build with faculty, friendships that you build with faculty, and he's certainly an example of that.
We're going to talk more as we go through this. I think we'll live through this, perhaps. Mr. Hyde, can we see Dr. Jekyll here?
Arkansas! Greetings from the mad scientists at UACCM. It's the Nightmare Returns Tour. Happy Halloween, everyone. Couldn't think of a better place to spend Halloween morning than here with you at home.
Exactly.
If you want to be mellow, you better go get some coffee now. If you don't want to be mellow and you want to have fun, you tune into that set and you get the rest of the family members gathered around. We're having fun today here.
I wish you would get into this. I just wish you would get excited about this. You have got like 5 chemistry experiments ready to do, and we're ready for this. We're ready for this, all with Halloween themes.
All right, we sure do. We are going to have a lot of fun with Halloween today. We're going to start by showing how the Halloween witch lights her way through the night skies of Arkansas. So, Mary Clark, I'd like you to pick up one of these solutions, the blue one. Steve, if you'd pick up this flask here.
I will be happy to.
Colorless solution. And I could ask both of you to just pour 3/4 of the contents into that funnel, and let's watch what happens.
Okay.
You can do yours at the same time as Mary, simultaneously.
We'll do it at the same time. 3/4, that looks about it, huh, Mary? Ooh, how about that?
Very good. Ooh, what you're looking at here is a very interesting reaction. Now, I understand for those of you at home with all these lights, it's kind of hard to see, but this is giving off blue light. If this was dark, you'd see blue light emanating from that flask. So this is very similar to what a firefly would do, or a deep sea anglerfish when it gives off light down there in the ocean. It's an example of chemiluminescence. One chemical is reacting with another, and in the reaction, light is emitted. Here it happens to be this nice blue light.
And you say not the least bit dangerous at all?
Not the least bit dangerous. Room temperature, it's not even hot to give off that light.
Okay.
The little fumes coming off is because I put a little piece of dry ice in there. But our motto in our chemistry lab is bigger is better. So instead of a small piece, let's get a big piece of dry ice. Now this is very cold stuff. This has been cooled down to minus 67 degrees Celsius. At that temperature, the CO2 under pressure turns into a solid. If we put that solid into some water here that's got a little bit of a blue chemical into it, what do we see happening? We've got instant cloud formation. So this stuff is so cold, when the bubbles of CO2 gas rise to the surface, the moisture in the air here, we always have humidity in Arkansas, is condensed to form a cloud. And since the carbon dioxide gas is roughly twice the density of air, we can see it floats downward through air. So it gives us a nice eerie effect where the fog crawls along the floor.
So dry ice and just colored water did that?
Any water will do it. You bet. You can put it in punch and carbonate your punch if you'd like to. Now this isn't just any colored water. I actually have a chemical in here that's sensitive to pH. So as we do some more experiments, we might see the color of the solution change. The dry ice tends to acidify the solution. Below a pH of 6.8, this color is going to change from blue to yellow. We'll see if we've got enough time to let that happen.
Yeah, let's keep moving because
we'll keep moving, you bet.
All right, what's next?
If you snooze, you lose. This guy took too much time in chemistry lab. Look what happened to him. Okay, for our next reaction over here, we're going to have a little fun. We're going to have fun with hydrogen.
Turns on the flame. I have my flame retardant jacket on today, by the way.
Let's see. I like quality testing.
Oh, that's okay.
Now, anyway, what we're going to do at this point, I went ahead and filled 2 pop bottles up here with a mixture of hydrogen and oxygen. When hydrogen and oxygen is heated, especially in a flame, we get a chemical reaction. Now, I'll hand this one to you, Mary. Steve, you get this one. And what we're going to do, I'll move the flame back a little so you can access it easier. You're going to remove the stopper, and within half a second, hold the opening of the pop bottle in the flame. Mary, let's start with you and see what happens. Whoa! Whoa! Very good. You're quite the chemist. You get an A in my class for the day. All right, Steve, you think you can top that?
Well, you told me before we go on the air that mine was going to be the big one.
I lied. We'll see. Oh. I didn't lie. Oh, no. Chemistry instructors never lie.
Oh.
Very good.
Ay, ay, ay.
Aye, aye, aye. Hopefully you can all hear it.
Mary, how many chemistry labs have you gone through there at the university? You're probably on the third or fourth one.
I keep repeating it.
There we go. Oh, this is a lot of fun. Actually, Steve's bottle here I filled up with 1/3 oxygen and 2/3 hydrogen. Mary's bottle I filled up with 2/3 oxygen and 1/3 hydrogen. And what we see is the optimal ratio when hydrogen reacts with oxygen is in a 2-to-1 ratio. So actually Steve's is the optimal ratio for the loudest bang for your buck.
I believe we were
Mary's
there.
was impressive, but certainly not quite as loud. So you got a pop bottle when you've got 1 oxygen mole. You get a poop bottle when you have 2 moles of oxygen. Mary, you had a poop bottle. Steve, you did good with a pop bottle.
I think,
outstanding.
yes. Will you take a breath there for just a minute, Chris, because I want to talk to Mary a little bit more about the other things going on at the school besides just chemistry. And I don't know how you couldn't sign up for this class. This is a lot of fun. But you're a 2-year institution. Folks can get a jump start on a 4-year degree, or they can just get into the workplace pretty quickly, can't they?
That's right. We have the comprehensive programs and career training programs, technical, health-related, professional service-related areas. Students, if they want to go out into the workforce fairly quickly, they can come in and get an associate degree in 2 years, go right out into the workforce, or if they want to get a head start on their bachelor's degree, they can go 2 years at UACCM. There's some legislation out there, the Arkansas College Transfer System, that ensures the transferability of courses, general education courses, from one institution to another. So students who work closely with advisors can take the first 2 years of their bachelor's degree and then transfer to a larger university.
They don't have to take redundant courses when they get to their next place.
And the benefit of that, obviously, is they're starting out smaller classes, typically the first 2 years, building a strong foundation, and also saving about half price on tuition that they would pay at a 4-year institution.
Gotcha. Mary, we've got time, unfortunately, just for one more quick one, Chris.
We could have 2 real quick ones. Here we go.
Okay,
Mary, you
very
talked
quick.
too long. See, we're going to have fun with chemistry.
Okay.
Make time for this one. What I'm going to do is take this large test tube I filled with nitrogen oxide gas. I'm going to introduce a chemical called carbon disulfide. Let me do that real quickly.
By the way, our drink mixture here is turning green.
Turning yellow, yeah. Okay, we introduced that. Now I'm going to real quick shake this up so that it'll vaporize.
Okay.
That chemical, carbon disulfide, is a liquid, but it has a very high vapor pressure, which means it's not going to take too much time to go to the gas phase.
Okay.
I realize we're short on time, so we'll try to speed this up.
Yeah, there's nothing like rushing through a volatile chemistry
There we
experiment.
go, exactly right. One with the potential for lethal explosion effects.
As Mary and I take 2
Now
steps
I'm going to
back.
go ahead and set this into the rack. And to initiate this reaction, I'm going to do a very interesting thing. I've got a regular cotton glove from Walmart, give me a little endorsement. Nothing special about this glove. I'm going to dip it into this liquid that is a little special. I'll tell you in a minute why. If I go ahead and put that into the flame, we can see that liquid catches fire. If I now use my flaming hand to initiate this reaction, ooh,
Okay, then.
outstanding, hoorah!
Very nice, Chris.
We had a
Thank you
reaction
so much.
between nitric oxide and carbon disulfide. Let's do one last one for you.
I'm afraid we don't have time. I'm afraid
time
we
for
don't.
one more. Time for one more in this world.
Well, there'll
Here
be
we
no
go.
commercials and no other segments on this program. Really, Chris, we're going to
You
have to
scored
wait.
today.
You look terrific. Mary, many
Okay,
thanks.
next
We appreciate
Halloween,
it.
we're going to move up a notch.
To be continued, the encore
To
next
be
Halloween.
continued. Happy
Absolutely.
Halloween, Arkansas. You're beautiful. All right.
I think you're too close to the fumes. More information on the University of Arkansas Community College at Morrilton on your screen. We're back with more Good Morning Arkansas right after this. Don't go away.